Okay, we on. Yes. I'd just like to echo what Kirsty said. It's so wonderful to physically be here and see people who aren't just pixelated faces, and to see that, below the face as well. I met my colleague for the first time a couple of days ago. He's got such thin legs. It's amazing. Yeah, you would never guess. So this is the title of my talk. Testing as an equal first-class citizen to coding. And there's a slide there that my colleague JC put together. He's a whiz at that kind of thing. And I'll explain what I mean by that, because it's a little bit cryptic. It all will hopefully become clear. So a little bit about me, the usual blurb. So a lot of you I know because I used to visit Oslo a lot before COVID happened. I was a self-employed consultant, trainer, whatever you call it, for over 20 years, traveling the world when you could still do that freely. And I came to Oslo a lot, and I love it. And I love the companies that I visited here. And I saw I'd never go back to being a regular employee rather than being self-employed. But my friend Mike dangled a carrot in front of me that was just too tempting. The prospects for this company that I joined in March now were just too enticing. We are expanding. We're going to have some really exciting news coming up in the coming weeks and months. And we're hiring, which is what I know all keynote speakers say you're hiring, even if we're not hiring, because it's a good way of getting people to come and talk to you. But we genuinely are hiring, okay? Okay. Hello. There we go. So first, a little caveat. Obviously, if you've looked at the outline and for the agenda, the speaker was originally planned to be Jason, is that right? Yeah, Jason. But he couldn't make it. He lives in America somewhere, I guess. Obvious problems, so he's not here. You got me instead. I am the substitute. I actually had COVID more than a month ago after having 2 jabs. And I've still got a slight cough that keeps coming back, so I think we'll be all right. So yeah, I'm the substitute. Boy, it's warm up here. I'm just going to take these shoes off if you don't mind. In fact, I say I'm the substitute. I'm not even the substitute. Because after Martin had asked would I do the keynote, and I said, yes, I'd love to, he accidentally let slip that he'd asked 7 people before me. And they'd all had the good sense to say no, to decline. Okay, so yeah, I'm the reserve substitute in the C team in the 4th division of the Exeter and Barnet League, sponsored by Tesco. Right? But I think we'll have a good time. Let's hope so. Now, you've all got a pen on your chairs. You've got to all grab your pen. Yep. Black pen. And we've got some very exciting new technology which we're going to trial for this keynote. The pen works as a regular pen, but it also has a microphone inside it and a transmitter. Okay, amazing, isn't it? The way it works is very simple. It's not very common to get audience participation during a keynote, but we're going to try it this time. So the way it works is I reveal a slide with a question. You have to make sure you have your pen in your hand. Yeah, ready. And then you speak the answer into the pen. Simple as that. Okay? The transmitter transmits your answer to the server. Where's Bjorn? Bjorn here? There he is. Yeah, Bjorn's running the server. It is brand new technology, but he assures me it's absolutely fine. There won't be any problems. Well, let's hope so. The server runs some voice recognition software, translates it, gathers the answers, collates them, generates a slide, inserts the slide into the slide deck, and when I get the okay from Bjorn, I can reveal the slide. You can all see what everyone said. Yeah, amazing, isn't it? Now, if you don't know the answer, please say equal rights for tests. Yeah? And that won't appear on the answer list. That one's the filtered out one. It's just so that everyone actually says something, because it's all going to be terribly, terribly flat if I run this gag and no one says anything. Okay? So let's practice. You have to say equal rights for tests. Let's go again. Equal rights for tests. If you don't know the answer, that's what you say. If you do know the answer, obviously, then say the answer. Okay? Brilliant. So we've got a demonstration from Martin. Can we come up, Martin? Yeah. Okay, got your pen? Yes. He's ready. Okie dokie. The slide, yeah, don't look at me. Look up here. This is where the question's going to be. This is just Martin. Everyone, please be quiet. Okay, don't speak into your pens yet. You ready, Martin? Yes. Okay, here we go. Ready? There's a clue in the slides. When you get the ones that you're participating in, yeah, look at the background slide, might give you a clue. Okay, here we go. Ready, Bjorn? Okay.
An African or European?
Oh, round of applause. So we got the okay from Bjorn. Oh. What's happening, Bjorn? Just a sec, okay. Try now, okay. Hooray! Thanks, Bjorn. So that's how it works. That's how we're going to get a bit of audience participation. Any questions before we all do a practice together? That one's a genuine question. That's not a question you answer into the microphone, into the pen, okay? Okay. Are you ready? Yeah. No, you're not. No one's got their pens up. Pens up. Pens by your mouths. Ready? Okay, remember, what do you say if you don't know the answer? Brilliant. Okay, here we go. Oh. We okay? Okay, let's see what your answers were. Well, these are interesting answers. So, what? There's a lot of people in the room. Blimey. Was something happening yesterday evening? But some of you did get the right answer. The clue is in the background picture. Yeah, chocolates, full of glucose. And whenever we get a right answer, we get free chocolates. So, Martin, how are you going to distribute these chocolates, Martin? You're just going to chuck them. Okay, chuck them. Not all of them. There's a few questions. Okay, a few over here, maybe. Yeah. Oh. And to be clear, you get the chocolates if anyone gets the right answer. You all get a chocolate if anyone gets the right answer. Thanks, Martin. Okie dokie. Now, there is a reason I asked you all to introduce chocolates in this very strange way. I'd like to talk about what's happening in your blood glucose now, those people who have a chocolate and they've started eating it. Yeah? It's going to spike. But quite rapidly, it's going to come back down again, and it's going to hover around, and it's going to be brought back into regulation fairly rapidly. Yeah, assuming you have a healthy body in a mammal. Yeah, okay. It goes up and down, but it quickly comes back into regulation. How does it do that? How does it do that? Let's look at that. So when you eat chocolate with glucose in it, the amount of glucose in your bloodstream naturally goes up. And if it goes up unchecked, you get hyperglycemia, and it's very bad, and you die pretty quickly. Now, that doesn't happen, of course, because there are some muscles. Where are they? They're in some cells in the pancreas that detect the increase in glucose, and that's their trigger to start creating insulin and pumping that into the bloodstream. Yeah, that's important because the liver and the muscles detect the increase in insulin, and that's their trigger to grab the glucose from the bloodstream and convert it into its stored form called glycogen, which has the natural consequence of reducing the amount of glucose in the bloodstream. It's being pulled out and stored in a different form. And so you don't get hyperglycemic and you don't die. Wonderful. Except if it goes down unchecked, you're still going to die, except you're going to die from, technically, from hypoglycemia rather than hyperglycemia. Well, who cares? Yeah. This doesn't happen also for a very similar reason. Yeah. Some different muscles in the cells in the liver and muscles detect this happening. That's their trigger to secrete a different molecule called glucagon. Some other cells in the pancreas, whose name I forget, detect the increase in glucagon. And that's their trigger to take the glycogen, which is a stored form of glucose, if you remember, yeah, and turn it back into glucose and pump it back into the bloodstream, which has the natural consequence, yeah, of bringing the amount of glucose back up again. And so that's how it works in a healthy mammal. This is an example of the equilibrium law, sometimes also known as Le Chatelet's law. If you look up Le Chatelet on Google, you'll find black and white pictures, because this has been known for a very long time. He was a French chemist from a long time ago. And I paraphrase the equilibrium law with this wording. Actually, that might not be fair. I might have actually, now I think about it, have stolen it from the Systems Bible by John Gall. Anyway, stable systems tend to oppose their own proper function. And I have to be completely honest, when I was younger, I really didn't get this at all. And looking back, I think part of the reason I didn't get it was because there was this idea of you're opposing your proper function. Why would you do that? Right? Okay. But now I see, of course, yeah, I see what it means. And it's a way of creating a system that has a chance of staying in regulation, that is regulated. Yeah. And I find it deeply beautiful and deeply paradoxical for many reasons, which I'd like to talk about. So the first one is, again, coming back to this idea that I didn't get it when I was younger for lots of reasons. And I think it was partly that, for various reasons possibly, I have a bias towards thinking about things in a static sense rather than thinking about them in a dynamic sense. Yeah. So to use the example on the slide background, there's a picture of an eagle there, I think, eating a rabbit. So fairly obviously, eagles regulate the number of rabbits in a fairly brutal way, right? But rabbits return the favor, right? Yeah, it's a co-evolving system. So as Charles Darwin might have said, but didn't, evolution is always co-evolution. You're always evolving against something else, with something else, yeah? In a relationship with something else. And now I'm committing one of my own biases. I'm using the singular. It's not necessarily just one thing. There's a web of relationships, of course, going on, yeah? They're all co-evolving together in an incredibly complex web of interactions which somehow has some unbelievable level of stability, yeah? As I say, I find it deeply beautiful and deeply paradoxical. I think I need to stand this side better. So I'd like to just put a slightly different twist on that. One of my favorite books by Bradford Keeney, The Aesthetics of Change. This is a quote directly from it. He says, all change can be understood as the effort to maintain some constancy, and all constancy as maintained through change. Strong echoes of paradox there. Remember the two glucose cycles? Yeah. You don't see them, but they're there. They're fighting against each other. They're fighting against each other. Fighting against each other. All this tremendous activity inside the cells that you can't see. Fighting, 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 fighting against each other. Fighting. Why? Why all this activity? To keep something else the same. There's that paradox again. Yeah. So thinking about that a bit further, we could start to reason that if there is something that is being kept constant, it's a pretty good assumption that there's going to be something actively keeping it constant. Might not be true, but it's a reasonable hypothesis, right? Yeah. Might be worth looking to see how that works. If you want to know how things change successfully, which you might do for lots of reasons, maybe it's worth thinking about how things don't change successfully as well. Yeah, think about the two things together, co-evolving together. Much richer way of thinking about it, for me at least anyway. And this is the way that structure is built. Yeah, if you want to build something with activity, it's hard to do that without a floor of stability underneath you, right? And you, as the activity on the floor, create another level of stability in the roof above you. Yeah, they each give a roof and a floor to each other all the way down. This is how structure, one of the ways that structure is built. And as is always the case, you can see strong echoes of this idea, particularly this idea of do people think statically or dynamically in the language that they use. One of the things I learned as a consultant when I used to travel the world, as I say, was it really pays to listen to what people say very, very carefully. Because if you're entering a new environment that you're not familiar with for the first time, it's pretty important that you get a handle on the culture. There's no point giving people advice if it's just not appropriate advice for the context they're in. Yeah. That's not a successful way to be a consultant, yeah? So listen to what they're saying, because what they're saying is your primary clue about how they're thinking, yeah? And what the culture is that you're being immersed in suddenly, yeah? It's the way language works. What do lights do? They light, yeah? What do irons do? They iron, yeah? When Mr. Hoover invents a machine for sucking dirt off the carpet, no one's going to go around trying to sell a machine that sucks dirt off the carpet. No marketing nous there at all, okay? You need a snappy name for what it is. It becomes a Hoover, and the act of using the Hoover becomes a verb. Hoovering, yeah? Nouns and verbs. This echo. And we see reflections of this in the language that we use, certainly in English. Language is endlessly fascinating. It's just such a shame you're not taught it that way when you're at school. Anyway, so when I put the word proof up, I'd like you to just pause for a moment and think about what ideas pop into your head when that word proof comes up. Are they noun-based ideas or are they verb-based ideas? Or are they both? Yeah. And maybe I've biased things a little by putting up some bottles of Singleton, which, by the way, is the only decent Singleton, right? And even that isn't one, right? Certainly for my answer to that question is I had quite a strong bias about thinking of proof as a noun in the mathematical sense. A mathematician's written a proof. Here it is. It's a finished thing, right? But if you study language, and particularly if you look at this word proof, it's very interesting. It used to be the case in English that there was a thing called a proving ground. And the proving ground was the place where you could go to determine if the spirits that you were buying from some seller were genuinely what they claimed to be. Did they have the alcoholic content they claimed to be? It's, for vodka, for example, it's a clear liquid. You can't tell just by looking at it. They could be claiming what's vodka, 80% proof? Something like that, isn't it? Yeah, let's say 80% proof. I don't know why I'm asking you. Well, there we go, yeah. But you don't know. They could be ripping you off. It could be much less alcohol. Okay, so they had a way of finding out. There would be a little place in the proving ground where you'd put some gunpowder. I'm not making this up, some gunpowder. And you'd pour a little bit of the supposedly proof alcohol that you're buying onto it, and you would try and light it. And if it had sufficient alcohol, it would light, and if it didn't, it wouldn't. It was a proving ground. It was an act that could be successful or not, kind of like a test, right? And this is, I think, the last echoes we have of that use of the word, with this strange system they have for telling us how much alcohol there is in the various alcoholic drinks that we buy. Yeah? Nouns and verbs, nouns and verbs. How do we think? Are we biased towards one? Would it be slightly better, more enriching, if we could alternate between the two? Have a co-evolving system between the two. I don't want to give the impression that you should drop the static thinking and just do the dynamic thinking. If I give that impression, I've not been successful, okay? Co-evolving systems is what we want. Static and dynamic in relationship to each other as another way of thinking, yeah? As Yoda might say, always two there are, right? Okay, whoopsie. Now this whole idea of things being in regulation and coming back to some level of stability has a word. All languages create words for these things, and the word in English is homeostasis. Isn't that interesting? The word we choose to describe this tremendously rich interaction that I described is not focused on the dynamics that create the stability, it's the stability. It's not homeodynamics, it's homeostasis, right? There is a bias, I think, to the way we think about these things. And I personally get a much richer enjoyment of my world when I can enhance my thinking by having these two things in opposition to each other. Come on. So this is one of the ways I like to try and encourage you to think about tests as equal first-class citizens. Yeah, we have coding and we have testing. And I think it's certainly true to say that 10 years ago or so, when DevOps took off, people suddenly had motivation to start to do some decent testing because they realized that if you've got a CI pipeline that works with, let's say, 1 commit a week, and you suddenly decide you're going to do 50 commits a week, it's not going to work, right? You haven't got enough quality, all things being equal, to go from 1 a week to 50 a week. You've got a 1 a week system. It's stable at that level. Yeah. If you want to increase the deployment frequency by a factor of 50, you're probably going to have to increase your quality by a factor of 50. And people wanted the increased deployment, and so they were motivated to learn how to get the extra quality. And suddenly, we had a really good motivation for learning about testing. I saw this so strongly when I was traveling the world as a consultant. But even in those places, I still perceive testing as being not an equal first-class citizen. Yeah, and I think you get a much richer perspective if you treat the two as equal first-class citizens with equal rights. Yeah. And I'm going to explain what I mean by that in some more detail. Okay, so just a quick pause here. I became a granddad just over a month ago for the first time. It's fantastic. I love it so much. Yeah. There he is. He's called Kobe. And I'd just like to point out, well, I mean, partly I put it out because he's so cute, but also he and I and every single one of you comes from an unbroken chain of survivors that's lasted roughly 4.5 billion years. Isn't that unbelievable, right? This regulation, this homeostasis, this way of keeping things in some kind of balance is unbelievably robust. The lessons you can learn from it really, I think, are worth learning. This stuff works, okay? Well, another way to think about it is there's been 4.5 billion years of destructive testing and you're still here, right? It's unbelievable, unbelievable. It's miraculous that we're here on this tiny little planet floating around, yeah? And some intelligent life exists here, right? Maybe it exists nowhere else in the universe. Isn't that amazing? Maybe it does exist elsewhere in the universe. Isn't that amazing too? Yeah? Okay. And now for something completely different. Sticking with the Python theme. Okay? Suppose a car's safe stopping distance is 50 meters at 50 kilometers an hour. That's roughly 3 seconds. Could you stop in 3 seconds without a brake? Now, There's a lot of smart people in the room. Some of them probably have a physics background, so don't shout out answers, okay? There are probably ways you can do it that are really, really clever, okay? I mean, some of them are obviously not very clever. You could drive into a handy wall that was a solid wall, right? That would do it. You'd stop in 3 seconds then. So it is possible. But the car wouldn't fare very well. It might be a write-off, okay? It might be the last thing the car ever does. And you might not suffer so well. It might be a problem for you. You might be in hospital for a lengthy period of time. It might be the last thing you do as well, or quite literally. And the car and the person, and let's not forget the wall. The wall doesn't suffer, so it's going to have to rebuild as well. I think we can say it's not a very practical system, okay? So with that in mind, pens at the ready. Let's wave those pens. Come on, let's see those pens. Wave those pens. Okie dokie. Are you ready? What do you say if you don't know the answer? Yeah, see, you're going to remember it now, aren't you? Right? Here we go. Okay, some people giving answers, some people reluctant to say equal rights for tests. They don't want to make it obvious that they don't know an answer. How are we doing, Bjorn? Are we okay? Okay, let's see. We really are filling up at the back, aren't we? They're both right. It's hard to argue with the noun correspondence here. We do have brakes to brake, but as we just discussed, a sensible person is probably not going to actually drive a car that doesn't have any brakes. Although having said that, I just remembered I do have a friend, he's a nutter, and he drove from London to Brighton just on the handbrake. But I wouldn't recommend it. Yeah, but equally, therefore we can say that there is a verb-based answer here. Yeah. We have brakes so we can drive safely. If you want to go at a certain speed, it pays to be able to stop within a certain distance, which corresponds to a certain amount of time. We're always trying to regulate based on time, I would suggest. Yeah. And the heavier you are and the faster you're going, the more important it is that you have good brakes. It's not an accident that lorries, for example, have a different kind of braking system. They often have a system called an induction braking system, right? There is some kind of balance you need. And so this, again, is the way I'm encouraging you to think about testing and coding as equal first-class citizens opposing each other. Oh, thank you, we forgot. Yeah, you carry on. We'll do it in parallel. Coding and testing as equal first-class citizens. And the obvious analogy is that the brakes are the tests, right? If you want to go at a certain speed and you've got a certain momentum based on the size of your company, maybe you want to think about balancing that with a certain quality of tests, right? Depending on how quickly you'd like the system to get back into regulation. The two are obviously dynamically interrelated, right? And so we're going to look at that idea in more detail with just some simple ideas. 4 simple questions related to something as fundamental as the humble function. Yeah, we're just going to spend the remaining time looking at humble function. What is the coverage of a function? That's the first question. Oh, no. What is the coverage of a function? For example, simple statement coverage. So it's exactly as there's no tricks here. This is what we're describing. We've got some tests, and those tests poke a function called f, yeah, and we're interested in the coverage. So what happens when we run it? We have to instrument the code, obviously, so that we can gather the coverage when the tests run. That's all well and known, lots of tools to do that kind of thing. And we get a certain level of coverage. If we're doing statement coverage and the function has 9 statements, maybe we get 8 out of 9. we get some feedback, we can use it. Brilliant. Not interested. What is missing from this picture? Equal rights for tests. That's what you say if you don't know the answer. If we can apply some technique to the code, I think it is a useful habit to get into to at least consider whether you can apply the same technique to the tests. The tests are code in their own right, right? Now, when I first talk about this to some developers, there's a sort of glazed look goes over their eyes, right? They think this is mad. Why would you do this? For various reasons we'll sort of touch on in a minute, okay? Well, bear with me. So as I say, supposing we're missing the 9th statement here, and it can never be covered. We look at the output from the coverage, and there's a 9th statement, and it can never be covered. We're absolutely certain it's a dead statement. Maybe it's a declaration, something as simple as a declaration for a variable that's just not used in the function. We're happy that all of these functions, and others as well, give us the features we need, and that if we remove that line, the dead line, it's not going to break anything. The tests are going to still run. Brilliant. You've now got a way to see dead code, right? Are you confident enough to delete the dead code? How good are your tests? Do you think it's important to delete code, dead code? Or are there other things that you think are more important, that are more time pressing? There's time again. Yeah. Night trading used to trade on the New York Stock Exchange. They didn't think it was particularly important to remove dead code. And so on the 2nd of August 2012, they lost $450 million in a few hours because they had a trading system written in C++, and it had dead code in it, and they didn't remove the dead code. They didn't think it was important. And the roll of the dice came out against them on that day, and it was in C++. And what happens in C++ when you get some undefined behavior? The answer is it's undefined. That's why it's called undefined behavior, right? And on that particular moment, the program counter, when it hit the undefined behavior, jumped to the dead code, which hadn't been run, let alone tested, in years. Yeah, but what did it do? Automatic trading. Very, very fast. Automatic trading, very, very fast. Okay, computers are really, really good at doing the right thing very fast, but they're also really, really good at doing the wrong thing very fast too. Tests are important, and they no longer exist, right? Equal rights for tests. Equal rights for tests. So let's imagine, as I just described, this idea of we're actually putting coverage on the tests. There's no functions here. We're ignoring what the tests are poking, just to be clear. We're only looking at the tests themselves, and the tests are being instrumented. That was I just remember what the joke was. And so when we run the tests, they do what they normally do. They run and they pass, etc. Lovely jubbly. At this moment, we're not interested in that. We're just interested in the coverage. So test F1 has 14 statements. Test F2 has 23 statements. Test F3 has 19 statements. What's the coverage? What are we going to get? Probably equal rights for tests. Thank you. This is what I thought, because I've been doing this for several years in CyberDojo. And it is true that the kind of obvious answer that was probably in your head was that you just get full coverage. I mean, they're tests, right? And that does happen a lot of the time. A lot of the time, if you do instrument the tests like this, you do get full coverage. But a lot of the time, you don't. And I mean genuinely, a lot of the time. And again, this was surprising to me, but now I realize it's totally obvious. If you have a system where you are treating the code and the tests as equal first-class citizens, and you're doing refactoring the code to keep it at a certain level of quality, you're probably going to be doing the same level of care and attention in the tests. They're both dynamic, they're both evolving. You have to keep them both evolving so that they have the same level of quality. If one is way worse than the other or way better than the other, it doesn't quite work the same, okay? And so we do things in the tests. And sometimes, for example, we have a similar situation to we just described before. Something very simple. There's a line in the test declaring a variable that's not used. It's dead code, for example. Yeah? Or you're in a class-based language, let's say, and you have to make the test functions member functions, and it matters if they're public, and you forgot to make them public. Right? Or the test framework says that your tests have to begin with TEST underscore, and you forgot the underscore. All kinds of reasons. Endless reasons why this can happen. And for one repository in CyberDojo, I actually use a particular Git commit message when I delete dead code from the tests. And for that repository, it's roughly 1 in 15 commits. I was amazed. I see it now and it's obvious, but I was amazed. Yeah? So full coverage for me is important mostly so I can see it when I don't have it. I can easily keep the tests at 100%. Easily. I can remove, it is worth my effort to remove that one line for the line that's not covered and to fix whatever it is that I'm fixing in the particular situation when the coverage has dropped because there's dead code. I do what it takes to get it back to 100%. Why? Not because that's important at that moment. It's because I want to be in that position to see the same thing next time. Right? But there's a bigger lesson, for me at least. Unless I have a way to detect and delete dead code, I will accumulate dead code. It will happen. I've seen it, I've experienced it in the tests. It's happening in the code, just like it was for night trading. Right? Have you got a way to find it? If you don't, it will be accumulating. Maybe it'll be okay, maybe it won't. Even if it's fine, technically, there's a carrying cost. This stuff is in your heads more than in the code on the screens, okay? And so I decided it was actually worth having 100% branch coverage for the code. It takes a while to get there, but once you're there, it's easy to stay there. Same message. Once you're there, it's easy to stay there, okay? But it's not easy to get there if you're not there unless you do it from the beginning. But it does have, for me, unexpected benefits. Question 2, what is the complexity of a function? Simple example, number of paths through the function. Sometimes called, I think it's called the McCabe cyclomatic complexity. Very simple idea. If there are 3 paths through our little function f again, then its complexity is 3. There's 3 different ways that that can run. What's missing from this diagram? Equal rights for tests. I've applied a tool to the function to give me some measure of its complexity, or tests of functions. I should at least consider if it's worth applying the same tool to the test code. I might not, but I think it's worth considering it. I might learn something like I did just a moment ago. Equal rights for tests. This is what I'm trying to get across. Equal rights for tests. Co-evolving system. So supposing we run the same tool on our tests, and there are 5 different paths through the test. So its coverage is 5. This is a problem. Because now the complexity of your tests is greater than the complexity of the thing you're testing. You've got less confidence that the tests are right than you have than the code is right. Right? Now, the way not to solve this problem is to create some meta tests that test the tests, and the meta tests have a complexity of 16. Not going to work. What do we want to do? Fairly obviously, we want 1. We want one path through the test, which by default is what you get. But again, if you measure this, as I do in CyberDojo, you very quickly discover it actually creeps up. Quite often, you know, it's got a little momentum of its own. It's creeping up because you're treating the code and the tests as equal first-class citizens. You're doing refactoring in the code. You're doing refactoring in the tests. If there's some commonality in the tests, you're refactoring it, yeah, into some commonality. Maybe that has a little bit of if code in it. It's possible. It happens for me in CyberDojo. I'm quite comfortable with it. Yeah, but I don't want to get it too high. I want it quite close to 1. Yeah, I want it to be specific. So there's another interesting word. What is the first 8 letters of specification, of the word specification? You're all counting in your heads now, right? Specific. You want the test to be specific. Yeah, verbs and nouns, the way you speak, the thoughts that they convey. If you want to increase your clarity of thinking, maybe you should think about increasing the clarity of your speech. The two are interrelated, obviously. Question number 3, what does a function do? It can do lots of things. We're not going to look at everything, obviously. We're just going to focus in, what does it print? And I'm not interested at all in what not a quote normal, I'm sort of being pejorative now, what a normal function does. I'm interested in the test functions. In this particular case, I'm really only interested in the test functions. So, hands up if you've ever thought a failing test was passing or vice versa. Come on, be honest. Very common, really, really common. Okay, assuming you're a dev, obviously. There's probably lots of people in the room who are not devs. That's not a great way to be. So I claim a test function should do one thing when it fails and something completely different when it passes. That's not like a normal function. A normal function is designed to do one thing and one thing only, and you want it to do that one thing. But tests are different. When you're using a test actively, in a TDD cycle, for example, there are moments when you're expecting the test to fail. You're in the TDD cycle. You've written a failing test. You're expecting it to fail. And then it passes, and now you're expecting it to be green. There's a duality there. There's a different state. And unless we're clear in our minds and in our output about what those differences are, you've got a way for the two things to get muddled together, and hence you get fooled, as we just saw. Often we are. Yes? So, to quote one of the giants of systems thinking, Gregory Bateson, what you want is a difference that makes a difference. A difference that makes a difference. I love that phrase. So if we start with the test function when it fails, it's quite easy. What we want is helpful diagnostics. Helpful diagnostics. Now, here's an area where we could have a second keynote, because quite often these are not as helpful as they might be, which again is an indication that we haven't quite got equal first-class thinking. This is a natural part of the feedback cycle which you can adopt and really make a big difference with. Also interesting, the word diagnostics, noun and verb. What should a diagnostic help you do? Diagnose. Does it? It kind of depends, you know, how helpful the diagnostics are and how much effort people have thought into that point, or whether they're just focused on getting it to green in the moment and not thinking about this aspect of time a bit more. And therefore, remembering Gregory Bateson's rule, we can say that when a test passes, you want almost nothing printed so that the difference between those two states is as big as we can make it. That seems a reasonable idea. So if this is the kind of thing that we get when a test fails, this happens to be from PyTest in Python, got to be Python, right? Then it meets the criteria that we're getting quite a lot of stuff. Sometimes it's more than we'd actually want. There's an art to doing just the bit you want, okay? And when we have passing tests, I don't like this. I think this is a crutch that people rely on. Yeah, I've seen cases where I've been sat next to someone and they've ran the tests and one of them failed. But they're running all the tests and one of them failed, but they're all running and all of them giving output when they go. And there's lots of them. And you see the red bit flash by on the terminal, right? And then there's green, green, and green, and green, and green, and green. You're waiting for it to stop. And the unit tests, they're running quite quickly, and it stops. And you think, OK, let's scroll back to the red test that failed and look at its diagnostic. You're scrolling, you're scrolling, you're scrolling, you're scrolling. And then you think, you look at the scroll bar size. It's minute. The little scroll bar is minute. You think, how much of stuff is here? Right? So you think you're not going to do it with this. You actually get your mouse and you put it on the scroll bar and you go straight to the top, right? It's not there. Your history's not big enough. You've lost it. I've seen that many times. It's really common. Yeah? You want minimal output when the tests pass. You want confidence that the tests were running, but that's about it. Even this is too much, I feel. It's just a crutch. Just print something that tells you the number of tests that were passing, and in your mind, have an expectation of how many tests you've got. If it was 906 and you've written a new test, it's going to be 907. It's not difficult. Okay? Last question. What do you name a function? I can feel my voice going. Oh. So this time we are going to think about both the naming of a function when it's a function and a test function. So we'll start with a function. Now there's a picture of some balance scales here because naming a function is difficult. It just is. And it's because naming all identifiers is difficult. It's having the clarity of thought in your head and then being able to express that clarity of thought with equal clarity, hopefully, with some quite high correspondence, I would suggest, in the code. Yeah, so often we struggle with the naming because we don't have that clarity of thought that we're trying to actually code. But there's another reason too, a much more syntactic reason, and that is the balance. Because we want readability in our code. But what does that mean? It means lots of things, but one of the things it means is that we want readability in the identifiers. But that's not right either. Because there's one time when the identifier occurs on its own, for example, and that's when you declare it. But other than that, the identifier's job is to be in an expression, right? To be combined via various operators with other expressions to form larger expressions that form operators in yet larger expressions. And it's probably the expression or statement level that you actually want the clarity and the readability and the understandability. And now it's tricky because you want the identifier to be quite small in the sense that if it's a long identifier and you've got a long expression involving, you know, the left-hand side that gives you the dot just to find the damn function in the first place, right? And then there's the function you call, and it's got arguments. You've got to have expressions for those. Some of them might be function calls too, right? And there's a return value, and that has to probably go into the assignment of another variable that we have to declare, and it's a statically typed language, so we've got to put the type of that as well, right? And it's a function. You can have as many arguments as you like. Maybe there's 127. In which case you missed one. It should be 128, right? It gets long very quickly. Yeah? So you can't make them long. You can't, if you make them as long as you might like, it's just unwieldy in the whole expression. But if you make them too small, it's no good either, because then you can't convey a meaning very well. This is the struggle we have, one of the struggles we have when we try and name these things, right? It's a balance. It just is difficult. Equal rights for tests. What about the tests? They're functions, they have names too. But they're different. And equal rights does not mean equal outcomes. It means equal opportunities. If the context is different and we have the same opportunities, the outcome might be different, and that's totally fine. We must be aware of the context. Style matters, right? So let's think about it. Naming a test function is different because test functions are different. It's obvious when you think about it. They don't have this tension. You're not calling the test function. The test framework is. There's no return type. Who would look at it? No one's calling it, right? There's no arguments. Caveat things like fixtures in Python. Yeah, if there were arguments, who provides them? We're not calling it. It doesn't work. It's not the way it's designed. And in well-written tests, there's no side effects. Yes? The trade-offs are different. And so we don't have this same tension in terms of the length. And so we write things like this. Yeah, very common to see tests with this sort of style, yeah, where we convey the specification in the name of the test, or try to. We do the best we can because we're not restricted. We can make it as long as we like, right? Pretty common. Anyone notice anything about these test functions? We can't see the right-hand side. Just a moment ago, we had the scrolling problem this way, and now we've got a scrolling problem this way. Yeah, it matters, this stuff. I think there's too much context to carry in a single identifier, and this is a mistake. What context do we have when we're talking about a test function? Well, there's many ways you can talk about it, but one of the common ones is given when then. Yeah, given we set up the test objects under test in a certain very special state, when we do the particular pokes of the object to try and cause them to do certain things and have certain behaviors, then we expect certain outcomes, and also certain side effects in externals, whatever it might be. That's a lot of words. There's a lot of context there, and you're trying to capture it in one function that wasn't designed to carry that much weight. Functions, as we just described, were designed to carry the weight across the structure of the function call. And it's creaking. You can feel it creaking. Yeah, you want to put new lines in here to split it. You want to put spaces, but you can't. You've got to put underscores instead. How about this? How about this? Right? This is what I used in CyberDojo. And we're also doing it in Merkely. It works for us. Okay? Now, there are trade-offs, obviously. Yeah? But there's more to it than meets the eye. So let's just revisit for a moment what it looks like if you do this. Yeah, to be clear, what I'm saying here is if we don't try and carry the context, this huge context in the name of the function, and it just wasn't designed to do that. I'm not saying throw the context away, because it did carry some level of useful information. It was just not in the right structure. Yeah, it had all this underscore stuff and the fact that you couldn't put new lines in. Although actually, if you try really hard, you can actually put spaces and new lines in a Python function name. You have to just do it via the global. Okay? There are ways of doing these things. Most people never look at them because they don't treat tests as first-class citizens, right? So one of the ways you can do it is in a docstring, for example, if you're in Python. Now, obviously, this kind of thing is easier in dynamic languages because when you actually get the diagnostic, when this test fails, it will print this. This is what you will see on the terminal. All of this, down to the point where the assert raise is somewhere down here, you'll see all of this. You can read the comment in the docstring. Now, as I say, that's easy in Python because it's a very dynamic language. If you have a language like C++, for example, much more static, not going to happen the same way, okay? But don't give up. There are ways and means of doing this. You just have to think about tests as equal first-class citizens and have a slight wrapper around your test frameworks in some way to actually make it do what you want to do. You have to arrange for the name here, yeah, to come in via some other mechanism, as an argument possibly, and then you hang this as a string off the ID. And now you can use the object that's coming in to do your asserts on, and it carries the context inside the string, which can be split across multiple lines, and it can have formatting as you like, very similar to given when then. Yeah. It just feels easier. And as a last benefit, you would make it easier to call the test functions, because I wasn't quite being honest when I said, you don't have to worry about calling the test functions because you never do it. The test framework does it for you. Some of you might be thinking, that's not right, and you're right, okay? When you're in the process of writing the tests, certainly I am often in the situation that I want to run just this one test. This is the one I'm working on right now. I've got enough in my head, thank you very much, without worrying about the effect on all the other tests and the state changes there. I'll get to that in a minute. One thing at a time. I just want to run this test and see if it's doing what I think it's doing for this little piece, right? And so you do want to name just that one test. I find it very common if you really adopt this TDD cycle, okay? Which I'm a total fan of because it's dynamic, right? And suddenly now these IDs are just so much easier. Imagine the old way a moment, the long test names. Yeah, if you're in a situation like you are in PyTest where you have to use a grep string to specify the test you want to run, you'd have to hunt through conceptually all of the names of all of the test functions, as long as they all are, and find the grep string that's unique across all of them. Yeah, no, if you're doing something and it's hurting, don't do it, right? You're allowed to want what you want. You might not get what you want, but that's a different question. You're allowed to want what you want. If you want to call the tests like this and separate the identity of the test from the specification of what that test does, that's fine. You're allowed to want that. And I do want that. And I do this, and I find it works for me. Okay? And now, all sorts of other things happen, because this is the unique identifier for this function in this test, but in the file, where there's a bunch of associated tests, these three characters are a common prefix for all of those tests, for example. And if I want to run all of the tests in the file, which again is a really common thing that I want to do, once I've got past the first one running and I want to go to the next level of what have I broken, right? That's what I want to do. And then typically when that's working, then I go to the whole level. That's a very common workflow, okay? And so I have ended up with a test style that does what everyone says you shouldn't do. The tests are basically test 1, test 2, test 3, test 4, test 5. It works for me. Yeah. So that's the end of all I had to say. I hope I made you think. Let's just do a quick summary. Please take away this idea of thinking dynamically as well as statically. Not one against the other, one with the other in a co-evolving system. Equal rights for tests. It's a way of thinking. For me, it's a way of thinking. Testing and coding in a co-evolving system, a stable co-evolving system. Have fun. Have a great conference. Be nice to each other and the planet. That's it. Thanks for listening.